class. If anyone have any question from the previous class, from the last class, from theory, basic theory of networking, like networking modes, types of network, types of communication, and from these three hardware component of network. Otherwise, if everything is okay, you don't have any question, you all have understood that, then let's start today class with again a very small question. Last class,
Sir, I don't have question from a previous class, but I wanted to ask about the syllabus. You haven't shared that with us.
I will share syllabus later. Okay,
And notes.
I will share syllabus later. You can, after the class, you can ask for syllabus in your WhatsApp group. I will paste there.
Okay.
Anything else?
No, sir, I'm good.
All good
Yes.
for everyone? Okay,
Yes.
great. Thank you so much, Prashant. Now you can keep yourself
Oh,
on mute. Yes.
hi, sir, this is my first day. So I just need to know about the lab setup. So we have to set up in our laptop, or we have any other,
Again, sir, we'll
uh,
talk about that separately. Don't
mhm.
worry about that. We will take care of everything. Okay. Right now, just I have asked you a student to set up packet tracer only, and it's very simple. Even if you need video on packet tracer, it is simple software. You can download it from the Google, and by clicking next you can install it. Even if you need help, you can chat with team, and someone will help you to set with the packet tracer. That's all. Regarding other softwares, I will guide you when it is required. We are going to install more than like 20 softwares, tools, Wireshark, Packet Tracer, GNS, EVNG, SolarBeam, SNMP, right? A small softwares, tools, and we will be using. So when we'll use in the class, I will also tell you how you can set up it. At the end of this course, we have some lab, complete enterprise lab with multiple branches. Even for some of you, it will be not possible to set up that lab in your system. I will give you the lab access. Right? Whatever lab you are not able to perform in your system, you can access our lab as well remotely. Our labs are accessible from internet. You can access it from anywhere. But regarding the lab and those all things, I will take care of it, and you can even chat with a team member to me after the class. Regarding course, syllabus, labs, right? Everything we can talk separately. Okay. So my simple question for today is how, even I had talked about this in last class, how we can identify devices in network. For an example, in my laptop, I have CCNA.pdf. Okay, a file I want to send to another PC in same office or maybe in different office in different city, anywhere. Requirement from source to destination, I want to send some data. How we can identify the device source and destination both?
Hello.
Yes,
With the help of IP address or host name.
host name. Okay,
Yeah.
so like let's suppose I have two PC. Host name is A. Host name means like PC name, right? Or on the
Yeah.
router
Right.
name of the device. B. Can I send traffic from PC A to PC B? Yes or no? Tell me anything. Any of you can answer. in last class also I had told you, like if I have just purchased 2 PC from the market and I have connected through one Ethernet cable, can they communicate? Can they exchange data?
No.
Yeah, they can
No.
exchange.
No, sir.
Yeah, it should be no for all of you whoever were present in yesterday class, right? It is not possible. It is possible. How we identify devices? With the help of two types of addresses. With the help of two types of addresses. I had told you physical address, like the place where I am sitting right now is unique globally, and the another address is logical address, like my name is Praphul, and there are lots of people in the world who are using same name. So with the help of name, you cannot send any data to me. You cannot send a letter from different city, from different country to Praful Mishra. No, not possible. Huh? But when you will attach my physical address, the physical location which is globally unique, then my address will become unique and you can send me anything from anywhere. So IP address is similar like logical address. And let's suppose my laptop is using 192.168.1.72 or 97, whatever. So lots of client machines are using this IP address. This is private IP address. It's reusable. I cannot send traffic with the help of this address if the destination is reachable through internet. If the destination is directly in my subnet, right, maybe that client machine will have one IP address from the same subnet, right? The confusing term over here for fresher is subnet. What is subnet? No worry, today you are going to understand this, right? So this part is actually the network part and this part is the host part. Network is like similar like your family, and whoever are family member, you can imagine those all as a host. Like in my family, family is, let's say, Misra family, and there are lots of hosts, me, brother, sister, dad, mom, wife, all are host. So whoever are in same subnet can definitely talk to each other. They are in local, in same network, in same building, in same room, you can say. But if users are in different subnet and reachable through internet, you can't send traffic, right? Because lots of private users are using this IP address. Internet cannot identify you or my laptop with the help of this IP. It is not possible. This is private IP. It is not routable from the internet. So one thing is private IP address, and the second thing is MAC address. Actually, first thing is MAC address, which is your physical address. And we had seen the one important use case of MAC address in last class. Switch forward traffic, layer 2 device forward traffic based on MAC address only, if you remember, right? So how switch uses or how switch takes forwarding decision based on layer 2 address, based on MAC address. MAC address is also called as layer 2 address. And second logical address is IP address. So we identify devices with the help of these two address: MAC address, physical address, and IP address. Let's understand both address one by one. Let's start with MAC address. What you guys knows about MAC address? Tell me, anyone? MAC address. Whatever you know about MAC address. MAC.
MAC address is the hardware address. It
Okay.
is unique address.
It, it is a 48-bit address.
Okay. It is a 48 bits address. Good. 1 minute. Let me write also. 48 bits address. Correct. Okay.
And it separate in 24 bits and 24 bits for a company and hardware company.
It is written in hexadecimal.
Divided into two parts.
Yes.
First one is called as first part
Organizationally unique identifier.
OUI. Okay. And second part Last 24 bits.
Serial number, sir?
No. Last 24 bits. Vendor assign. Your vendor is going to decide last 24 bits only, and with the help of OUI only, MAC address is globally unique. All the system has unique MAC address. How it's possible with the help of OUI? Because vendor is not going to decide their OUI. OUI is not free, and this is first 24 bits of your MAC address. Anything else about MAC address? Media access.
It is written in hexadecimal.
Okay, represented in hexadecimal. Okay, good. Anything else? Represented in hexadecimal. Great point. Next, anything else?
It is also called as bond-in address.
Okay, correct. We can call it physical address, born-in address, MAC address, hardware address, right? Lots of names are there. Any features or terminology of MAC address, layer 2 address? L2 address. If L1, L2, L3 is confusing you, no worry. Our next topic will be OSI layers only. So this is actually layer. Some of you are fresher. Okay, these are some important points, and it's absolutely fine. If I will talk about the range of MAC address, so it is going to be okay. If it is a 48 bits address and represented in hexadecimal, then can anyone tell me how many characters are there?
12 characters.
12 characters, right? Reason, one hexadecimal character carry 4 bits, because in hexadecimal we have total how many values?
15.
16. 0 to F. So with the help of 4 bits, we can represent 16 characters, 16 value. Like with the help of 2 bits, you can only represent 4 values. With the help of 1 bit, you can represent only 2 values. Like it can be either off or on. With the help of 2 bits, it can be 0, 0, 0, 1, 1, 0, and 1, 1. Similarly, with the help of 3 bits and 4 bits. With the help of 4 bits are required to represent one hexadecimal character. So total we will have 12 character. My lowest MAC address can be 12 times 0, 2, 4, 6, and 12. And my largest MAC address can be
12
12 times F. F is the last character na, of hexadecimal.
Yeah,
12. Right? My all MAC addresses are going to lie in this range, 12 times 0 to 12 times. Now, some vendor can represent this MAC address, same MAC address in different way as well. For an example, there is a MAC address 0A, then BC, then 1 not A, and then we can say how many, 2, 4, 6, and let me repeat it. This MAC address, right? It is in between this range, yes or no? This MAC address is in between the range.
Yes.
Some vendor can represent it like this. Some vendor can represent it like, let's say, there is one colon after every 4 characters. Some vendor, like some operating system, can represent it like this. Windows operating system, for an example. like this, like after every 2 character there is dash. Okay, so but there is no any difference in these 3 MAC addresses, all are exactly same. So representation depends on your vendor. On Windows operating system you will have different MAC representation, and in the last class on switch Cisco iOS operating system you had seen the MAC representation, right? Cisco represent like this, correct? Cisco. And Windows operating system represent like this. Here on my NIC you will see similar kind of MAC address, correct? All. This is what MAC address. How many characters are there? 12. And how it is represented like this. And if you will see, this is also from the range only. This MAC address. What happened? This is my laptop MAC address. It is from same range. Okay, so total length of address is 48 bits and each character carry 4 bits. So you can multiply 12 by 4, you will get 48 bits. Now this 48 bits, some of you said 48 bits is divided into 2 part. First 24 bits and last 24 bits. First 24 bits is called OUI, organizational unique identifier, which identify the organization, and last 24 bits are vendor assigned. Vendor is going to assign it. For an example, who is OUI? Who is OUI? Organization like INA. How many of you know about INA? No one?
It is an authority which assigns IP addresses to companies.
Yes,
globally.
Correct. It is a like non-profitable organization who manage IP, port, MAC, like addressing on the internet. Done. So let's suppose this organization has some OUI. Very first OUI is first 6 bits. Let's suppose 2, 4, 6. And second OUI is 1, 5 times 0, 1, 5 times 0, 2, 5 times 0, 3, like this. These are the OUI. And here are some vendor company, for an example, Dell, who need some MAC addresses for their NICs, HP and Apple, whatever, right? You can imagine some vendors who manufacture networking devices. So Dell, for an example, Dell need what first? OUI. From where Dell will get OUI? From the INA. INA is going to give, let's say, this OUI to Dell. So now Dell has one OUI and HP also has one OUI. Similarly, Apple will also have one OUI. Now tell me, with the help of one OUI, how many NICs or MAC addresses Dell can design? This is first 24 bits. This is reserved, right, for Dell. But question is, when Dell need to purchase again another OUI, because now there is no free space available. How many MAC addresses can be designed with the help of one OUI? Similarly, this can be the OUI of HP. Right? Or You can, yes, let me write here. So it depends on free bits. Total length of MAC address is 48 bits, 24 bits are reserved, so 24 are free. You can say 2 power 24. If you know the binary decimal calculation, you can understand it very well. 2 power 24 MAC addresses can be designed with the help of one OUI. Let's say Dell has their vendor assigned bits, means last 24 bits. In their last 24 bits, value is like this: 6 times 0, then again 6 times 5 times 0, then 1, 5 times 0, then 2, 5 times 0, then 3, right, till all f 6. This is what vendor assigned. How many bits?
But we
Last,
cannot use that F for any device, right?
wait, now let me finish. Or vendor assign bits. Okay, so maybe Dell and HP both are using same vendor assign bits. This is for Dell and this is for HP. Now both need OUI, both have OUI. They can just attach this OUI with all vendor assign 24 bits from here to here. From here to here can assign first 24 bits. Now all the MAC addresses, and similarly HP is also going to assign these all bits to their all vendor assign bits, 24 bits. And now you can see both the company has same vendor assigned 24 bits, but their MAC addresses are unique. MAC addresses are unique, like this MAC address and this MAC address, both are unique. How? With the help of OUI. Done. So Dell has unique MAC addresses, 2 power 24 MAC addresses with the help of one OUI. Similarly, HP also has 2 power 24 unique MAC addresses with the help of one OUI. And now both the company can assign these MAC addresses to their NIC port. Sometime to test your basic knowledge in interviewer can ask you this a question like this, that who assign MAC addresses to NIC or to the client machine? Vendor assign. It is vendor assign. Vendor assign this. And who assign IP address? You, network engineers. You guys will take care of DHCP or manual IP configuration, right, in the network. MAC addresses are already assigned to all the NIC ports on your system. Your system can have multiple NIC. If I will ask you how many NICs are there in your laptop, you should say, let me count how many ways are there to connect my laptop to network. If 10 NICs are there, it means you have 10 ways. You can connect through Wi-Fi also, through LAN port also, through Bluetooth also, right, through other interfaces also. We call it interfaces as well: LAN port, LAN card, NIC, or interface on the machines. Any question? How MAC addresses are unique and how two companies are going to identify that the MAC address which I am using right now, right, which I am designing right now, is unique. No one is using this MAC address with the help of OUI. Any question here? This is basic of MAC addressing, layer 2 addressing. Clear? Say yes or type yes in the chat if it is clear.
Yes.
Okay, good, good. Gopi
But I have
Verma,
one question.
Mhm.
We cannot assign that FF to any device, right? Or we can.
FF is a broadcast address. You cannot assign, you use it to send traffic to everyone. Right? The last address is called broadcast address, and first address even you cannot assign 000. Right? It doesn't mean this MAC address is not valid. We can still send traffic to broadcast address. Right? So last MAC address is reserved for broadcast. When we'll understand the R protocol works on broadcasting. So you will see destination MAC will be all F 12 times F. Anything else?
Thank you.
If all MAC address exists, then how they assign another new MAC address?
Again, you will purchase the OUI and you can use same vendor assigned fields. And INA is going to maintain a database that which OUI I have already sold. So I will not sell that again. So because of OUI only MAC addresses are unique.
Okay, thank you.
Second address is logical address, IP address. So tell me a few things about IP address now. Second address.
There are two IPs, IPv4 and IPv6.
Internet protocol address. IP stands for
Yes.
internet protocol. Internet protocol address. Length of IPv4 addresses. See, when I'm saying IP only, IP means not only for you to learn. IP means IPv4. In NANP, you are not going to run command IP version 4 or IP version 6. When you will only tap IP, it means device will automatically understand you are talking about IP version 4. So here also I am talking about IP version 4. IP address, I have not defined the version, right? When I will say v6, you can say IP, it is IP version 6. Right now, I'm talking about version 4. So what is the length of IP version?
32 bits.
4. Good, 32 bits. It is 32 bits address. And how we represent it?
In 4 octets.
Decimal.
Represented in
Decimal.
some of you say dotted,
Okay.
and
Yes.
some of you are saying decimal. So say dotted decimal, let's say. Represented dotted decimal. Right? You know the decimal value 1 to 9. 1 to 9. So, and how many fields we have? Like we divide a MAC address into two parts, first 24 bits and last 24 bits. Similarly, we divide IPv4 address into
Network part and
four
host
parts.
part.
Oh,
4 parts means first 8 bits, then second 8 bits, second 8 bits, then 16 bits, third 8 bits, and fourth 8 bits. And that's why some of you say octet. Octet means what? 8 bits. 8 bits is called as octet. Bits, bytes, 1 byte is called 8 bits. So each field length is 1 byte. Either you can say 1 byte or you can say 8 bits. Good. As I told you, you can represent 16 characters with the help of 4 bits. Now my question is, with the help of 8 bits, what minimum decimal value you can represent and what maximum decimal value you can represent? Minimum means what? Means when we have all bits 0, when all the 8 bits are 0, 1, 2, 3, 4, 5, 6, 7, 8. I can get minimum decimal value. This is what these all are bits in binary, and decimal can be 0. If you will convert this binary into decimal, it's going to be 0. And maximum value means when all the 8 bits are 1. Bits can be either 0 or 1. You all know this. So if all 8 bits are 1, then I will get maximum value. Maximum value is going to be what? If you will convert this binary into decimal, what value I will get? What value I will get?
256.
255.
No.
255. Right.
Very good. 255. Right. This is decimal value of this binary. It's a very simple binary to decimal convergence. In case if any one of you don't know how to convert binary into decimal or decimal into binary, after the class you can watch a small video right on the internet. Even you can ask me even right now also to explain binary to decimal. If you feel that it will be difficult for me to understand by watching YouTube video, you can ask me. It's very simple and very easy. Most of the time I have seen people know it. Binary to decimal convergence. So in each field my value can be from 0 to 255, and here all the fields are separated with the help of dot. That's why we are saying it is dotted decimal value. All the fields octet, either I can say octet because we have 8 bits and 8 bits is called as 1 octet, or I can say first field, second field, third field, like that. All the fields are separated with the help of dot. Here you will have 1 dot, here you will have 1 dot, here you will have 1 dot and 1 dot. Done. And in each field value can be from 0 to 255. So my lowest IP address can be 0 dot 0 dot 0 dot 0 when all the 8 bits in all the octet, all the fields are zeros. And maximum value can be like when all the 8 bits in all the octet are 1, then I will get 255.255.255.255. It means this is the range of my IPv4 address. My range is starting from 0.0.0 and going till 255.255.255.0, because in each octet we have 8 bits, and with the help of 8 bits 0 can be my minimum value, 255 can be my maximum value. All the IP addresses are going to lie in this range. If I will type on IP, let's say 192.168.256.10, is it a valid IP?
Yes.
No, this is not a valid IP
Oh,
address.
no.
In third octet value is 256, which is not possible, right? How you can represent 256 with the help of 8 bits? When all the 8 bits are 1, then decimal value is going to be 255 only, right? So by looking into the IP address, I can say no, this IP address is not a correct IP address, not a valid IP address, right? Because here value is 256 and we have only 8 bits in all the fields. So maximum value can be 255. Now is it the valid IP? Definitely yes, this is the valid IP address. This is my IP representation. Right, all the IP address. Even if I will show you the IP address of my laptop, even on any interface there are lots of virtual interfaces. You can see this is my VMware interface and this is the IP address there, 192.168.241.1. Is it from this range? Is it from my range? Yes, this is from my range. On other interface also, MAC address and here IP address 192.168.241.1. This is IP address on another interface. Sorry, I think I have copied the same IP. Let me verify it. This is VM interface only. Yes. So let me show you the IP address on another interface. Let's say this one, 192.168.192.21. See the another IP address. Here you can see 10.91.53.168, right? And you can check other IP addresses as well, like even on the browser. If I will show you my public IP address, what is my public IP address. Here I can show you my public IP address as well. You can see my public IP is 123.250.3.14.202. And you can see about my ISP and those all things. Okay. This IP address, public IP. All the IP addresses are from my range only, correct? Any IP from out of this range is invalid IP address, is incorrect IP address. Even for now, you should say 0.0.0.0, the first address. Soon I have told you first address is network ID and last address is broadcast ID, right? It can be used to send a broadcast traffic, and this can represent the family. Like you, as I have given you the example of my family and about the host who are living inside that family. So the first IP address represent the network, that you all these IP addresses are member of this network. Otherwise, imagine if I have a network in a company. Let's say I have purchased one switch, I have purchased one switch, and I have connected lots of client machines here. Let's say 100 client machines, right? Like you can have one switch and multiple switches, doesn't matter how you have connected. Let's suppose 100 devices are there and all has one IP address. Let's say IP address of PC1 is 10.1.1.1, PC2 is 10.1.1.2, PC3 is 10.1.1.3, and 10.1.1.4. So how switch is going to forward traffic between these users? Will switch use IP address to forward the traffic? Will switch use?
No, it's use
No.
MAC address.
Yeah, switch forward traffic based on MAC address only. But router, L3 device forward traffic based on IP address. So router need what? Routing table to forward the traffic. And in routing table, router store what? Network ID. If there is no any concept of network ID, what happen? Router have to install all these IP addresses in their routing table. If I want to send traffic to 10.1.1, I will send to switch. If I want to send traffic to 10.1.2, I will send traffic to switch. If I need to send traffic to 1.1.3, I will send it to switch, like this. If there are 1000 clients, router need to install 1000 entries. It can occupy more CPU and it will be difficult, like on any device who uses IP address to forward the traffic, to check any policy. For those all devices, it will be difficult to maintain a database for each and every IP address. So router is going to just install the family information. It is similar like, let's suppose I am living inside this building. My flat number is, let's say 701, right? There are lots of floors, lots of buildings inside the same campus, and I am living in 705. So maybe the guard who is sitting over here 24/7 don't know my name, don't know my brother name, don't know my sister name. But if there is a parcel for me, God can see the family. Okay, Praphul Mishra, that means it is from the Mishra family. I need to send it to 705. In Mishra family is living in 705. So with the help of family, God can identify all the hosts who are living in my family. God just remember the family information. Similarly, router is going to just store the information of network ID, which is going to be common in all the IP addresses. Like family Mishra is common in all family member who are living in Mishra family. Benefit, we can summarize the database. God don't need to remember the name of all person who are living inside the Mishra family. God know if parcel is for Praphul Mishra or Vivek Mishra or Meenu Mishra, just send it to 705 to the Mishra family. So first IP address is network ID, which represent network. Here this 0.0.0 is representing a big network. Network for entire IPv4 IP address. Right? Internet, all the companies, enterprises, network, data centers, everything is getting represented by this network ID 0.0.0. This is the network ID of IPv4 address. And when we'll divide the network, we'll understand lots of features, lots of classification, right? Then you can understand that we can have multiple network ID, because in this network, this is very big network. How many IP addresses are there? 4 times 0.0.0.0.02 255.255.255.255. If you will try to count, then first IP address is going to be 0.0.0, second IP is going to be 0.0.1, and it will go till 10.0, sorry, 0.0.255. After that, next IP address is going to be 0.0.1.0, then 0.0.1.255, and like this it will go till 255.255.255.255. Total number of IP addresses inside this network is 2 power 32. The total length of IP address 2 power 32. 2 power 32 is what? Values. 2 power
15 million.
around around 4 billion, around 4 billion, 4.9, sorry, 4.29 billion. If you are thinking this is a huge number, Praphul, no sir. We have shortage of IPv4 address. This is the reason why we come up with IPv6. This is the reason why you are going to run classification inside the same IPv4 address. This is the reason why you are going to learn subnetting. Why you are going to learn the NAT network address translation. The reason behind these all technologies, new addressing, is shortage of IPv4 address only. You can imagine the world, and even nowadays, even I am using lots of multimedia devices. Even my car key also need one IP address, so that I can remote it remotely. I can lock it remotely. Smart TVs, right? Kitchen product, IoT devices, all are using IP, all need IP address. All Bluetooth devices, Wi-Fi devices, sensors, in home automation, everywhere we need what? IP address. So we have shortage of IPv4. That's why you will also learn the private IP and public IP. As I said, NAT. Why we come up with NAT technology? Because of IPv4 shortage. Why we come up with private IP and public IP concept? Because of shortage of IP address. So 4.29 billion IP addresses are less as compared to demand. So one thing is clear: the range of IPv4 address, length of IPv4 address, and representation, how we represent it. And one more thing, that we have still shortage. Even we have 4.29 billion IP addresses, but still this is shortage. We have shortage of IPv4 address. And this is the range from lowest IP address to the largest IP address. And all the IP addresses, whatever you are going to learn, private, public, subnet, right, all will comes under this range only. Any IP address out of this range, like 1.1.256, is invalid IP. Is invalid IP. This is an invalid IP address. Invalid IP. Anyone have question here? Now we are going to understand how we have reduced the shortage. First, we try to reduce the shortage in IPv4, and then finally later we come up with IPv6, right? So right now, entire network, right, entire cloud, all the technologies are working on dual stack. IPv4, even I have told you in first class, plus IPv6. That's why still IPv4 is very important for you. Most of your routing protocols, switching protocols, firewall policies are configured, are already implemented over IPv4 address, and it is not so easy to replace everything from IPv4 to IPv6. So maybe in future our all the technology is going to shift over IPv6. Then you don't need to learn IPv4, but not at this moment of time. At this time, IPv4 is more important than IPv6. That's why you have few topics of IPv6 in NANP, and you have lots of topics in NANP on IPv4. So if it is clear, the basic, you can let me know. I can take it further. Clear? Okay,
Yes, sir, understood.
great. See, now to reduce the shortage, what we did first, we perform classification for IPv4 addressing. Classification. We have classified it. What it mean? Classification. We come up with a concept of class. Class in IPv4 addressing, like class A, class B, class C, class D, and class E. We design class for every major organizations, right? For every major departments where IP addresses are required. Like for large companies like Google, who has branches around the globe, will use IP address from different subnet, or ISP, who has very complex network, who is connecting multiple countries together, multiple cities together, will use IP from different subnet, from different class. And a user who is just sitting in home with 15 to 20 devices will never use IP from that class, will use IP from another class where will assign less number of IP addresses. And then from each class, again, we will use some IP address for public and some for private. I will tell you that concept also, private and public. Nobody first understand the classification. So what we did here for classification, we just used first octet, first field. You can say first field or first 8 bits, means first octet, are used for classification. Or it will be better even we are not using all the 8 bits. So I can say first field. In first field, in first octet, how many bits are there? How many bits we have? 8 bits.
8 bits.
Out of 8 bits, we have reserved 1 bit, first bit, the very first bit. The very first bit will be always 0. It will be always 0. This is first bit of your IP address. Now, how many free bits are there in first octet? How many free bits are there? 7. Total we have 8 bits. We have reserved 1 bit, right? We cannot change it now. Now 7 bits are free. So what will be the minimum value? When all 7 bits are zeros, then I will get minimum value 4, 5, 6, 7. And maximum value if all the 7 bits are 1. Like in IP addressing, as I said, if all the 24 bits, so all the 32 bits are zeros, then you will get minimum value. If all the bits are 1, then you will get maximum value. Similarly, in first octet we have 8 bits. I have reserved 1 bit, that is 0. Now we have 7 bits. So if all 7 bits are 0, then I will get minimum value. If all the 7 bits are 1, then I will get maximum value. 5, 6, 7. Now tell me what will be the decimal value of this binary. This binary, the total by 8 bit is going to be this one. First bit 0 and last 7 bit 0. And here
127.
it is going to be 0 only, right? All bits are 0. And here if you will convert this binary into decimal, you will get what?
127.
127. So if value in first octet is present from this range 0 to 127, it means that IP address belongs to class A. Class A. This is first class in IPv4 addressing, class A. Similarly, for class B, for another class, we have reserved 2 bit. That first bit will be always 1 and second bit will be always 0. So how many free bits are there? 6. So minimum value will be when all the 6 bits are 0 and maximum value when all the 6 bits are 1. If you will convert this into decimal, what value you will get? You will get 128. And if you will convert this binary into decimal, your value will be what? 191. You can check it. So here 2 bits are reserved, 6 bits are first and second bits are reserved and 6 bits are free. And this range is assigned to class B. And for class C, we have reserved 3 bits. First bit will be 1, second bit will be also 1, and third bit will be always 0. So free bits are 5 bits. If all the 5 bits are 0, 4, 5, then I will get minimum value, and if all the 5 bits are 1, then I will get maximum value. Again, if you will convert this into decimal, then calculate it. 128 plus 64. It is going to be 192. And here 223. This range is reserved for class C. It is for a small organization. A small organization. You will have 254 IP addresses. So if you have clients up to 254 in your network, you can use IP from class B for a small organization. For medium organization, class B. How many IP addresses are there? 2 power 16 minus 2. Around 65534. This is the total number of IP addresses in this class. So good for medium size company like ISP, tier 3 ISP. And class A, we have 2 power 24 IP addresses. 2 power 24 minus 2. Lots of IP addresses. So this is reserved for large organization. Class A for large organization, class B for medium organization, and class C for small organizations. Now, why we are learning this? Because in CCNA 200301, there is an exam. Please put yourself on mute, brother, please. Yes, in 200301 exam, there is a commonly asked questions, like in almost all paper, you will find similar questions. Base question is how many networks I can design from class A, from class B, or can ask you from class C, from any one class. Like from class A, most of the students are thinking to power 8. Now you know 1 bit is reserved, we cannot change it. So 2 power 7 network can be designed from class A. 2 power not 16, 2 power 14 network can be designed from class B. And 2 power not 24, 2 power 21 network can be designed from class C. Now, this is classification. This is classification. See, Second thing is here, I told you that this is network ID. This is network ID. This is broadcast ID. And this is host ID, IP address, right, which is assigned to host ID. But how we can identify the network portion? How you can say which part is network portion and which part is host portion? How a device can identify that this particular IP address belongs to this subnet only? Let's say router has one entry in their routing table 10.0.0.0 or 10.1.1.0/24. Soon we'll understand it. 24, and it is receiving a traffic. This network is reachable via switch. This network is reachable via switch, and router has one traffic. Router is receiving one traffic from any another device where destination IP address is 10.1.1. It is for this PC. How router 1 can identify that this IP address belongs to this network only, this subnet only? So there are two things inside any IP address. See, these are my IP addresses, right? In binary or in decimal, doesn't matter. IP address is in binary or decimal, meaning is same. Your IP address can be in binary also, like 0.0.0 can be also represented as 8 times 0, 4, 5, 6, 7, 8, and then in second octet also all zeros, third octet and fourth octet. There is no any difference in between these two IP addresses. Both are same IP addresses. Both are same. So either you can represent your IP address in decimal or it in binary, meaning is same. And in binary, we have only two value, 0 and 1. And 0 represent network bits. Network bits or host bit. 0, whoever knows or experienced one, or only want to learn CCNP, 0 is host bit or network bits. It will represent network portion or host portion.
Network.
Network portion.
0 is not network portion. 0 is host portion. 0 is going to represent the host portion. Like you can see IP address on PC number 2 is 10.10.1.1.2. What is common in both the IP address of PC1 and PC2? First third octet value. This is common.
Yes.
This is actually network portion, right? Or you can say even first octet value. First octet value is common. So it can be network portion, which is same like in all the family members name. And host is which is changing, like 1, 2, 3, 4. Fourth octet is here host. So maybe inside this single IP address there are 24 network bits and 8 host bits. I don't know, but maybe 10 network bits and rest all host bits. How we can identify the network bits and host bit inside any particular IP address? To identify,
Using subnet mask.
By subnet mask.
correct. To identify network bits and host bits inside any IP address, we have a tool, a marker that is called subnet mask. Subnet mask is going to tell you how many host bits are there and how many network bits are there. If bits is 1, it means this is network part, network bits, and if bit is 0, it means this is host bit. And for all the classes, class A, class B, class C, even class D and class E, we have two more classes. You can see my IP address in class C is ending over here on 2 to 3. What about the rest IP address from 2 to 4 to 255? So those IP addresses are reserved for class E and class D. Class D is again reserved for research purpose, like NASA, ISRO. These organization uses IP from. No, class E is reserved for research.
Multicast for
D
class
is
D.
reserved for multicasting. Yes. In last class, I had told you multicasting is very popular technology, right? When we want to send traffic to multiple devices, we will send it on multicast array. So when we'll learn the multicasting, that time we'll explore class D addressing. Right now we are going to learn class A, class B, class C, because these classes are used for unicast communication, unicast and broadcast communication, right? And in the companies we use IP address from these classes, from class A, class B, class C, not from D and E. We'll use IP from as a network engineer you need to learn class D also, because multicasting is part of our even course, and we are using it everywhere. All Netflix, YouTube Premium, whatever videos is streaming, all are streaming on a multicast address, and once you will join that multicast group, you can start receiving the video, right? How subscription work, like until unless you don't have subscription of Netflix, you cannot watch the movie, means you cannot join the multicast group, and until unless you cannot join the multicast group, you cannot watch the video. So we'll talk about that later. For class A, class B and class C, we have a predefined subnet mask. For class A, 255.0.0.0. For class B, 255.255.0.0. And for class C, 255.255.255.0. Now you tell me how many ones, means network bits, are there inside this subnet mask, and how many zeros, means host bits, are there inside all the subnet mask inside class A, class B and class C. Tell me, 1 minute.
In class A, first octet is the network bits, and last three octets are the host bits.
Yes, how many network bits are there? So you need to just check how many ones are there, right? So in first octet we have 8 bits, and decimal value is 255. It means what? It means if I will convert this subnet mask into binary, then I will get this binary only. 255 binary is going to be 8 times ones, then 1 2 3 4 5 6 7 8, 8 times 0, because decimal value is 0, it means all the bits are 0. In third octet 0, and in fourth octet also 0. This is binary of first subnet mask of class A. Binary of this subnet mask class B is going to be this one. Yes or no? And binary of
Yes.
class C is going to be like this. Correct? So now you can count it easily, that Praphul, in first subnet mask which is reserved for class A, has 8 ones, means 8 network bits. In class B, 16 network bits. In class C, 24 network bits. And in you can also calculate the host bits, number of host bits. Even if you only know network bits, let's say I am telling you that I have one IP address 10.100.25.200, and there are 25 network bits. So can you tell me how many host bits are there inside this IP address? How many host bits are there inside the IP address? I told you the network bits and IP address. I want to find the host bit.
7 bits.
So we know total length of IPv4 address is 32 bits. Out of 32 bits, 25 are network bits. It means 32 minus 25 is host bit. Yes or no?
Yes.
So if you know the network bits, you can calculate host bit by yourself as well. But subnet mask is telling you both network bits and host bit. Later we are going to replace subnet mask. Subnet mask is old way of implementing IP addressing. Nowadays we are using CIDR, at the slash value, slash notation of network bits. Okay, so in CIDR you can only see the network portion, network bits, how many network bits are there, and you can calculate host bit by subtracting network bits from 32 bits. Good, go ahead. So now next thing is in class A, this is very important. In class A we have 8 network bits and 24 host bits. With the help of network bits, you can design the networks, multiple networks, and with the help of host bit, you can assign IP address. You can get the actual IP address which you can implement, which you can configure on the host machine. But in class A, we cannot design to power 8 networks because we have 8 network bits. Out of 8, 1 is free, that is 0. Right? So here in subnet mask, it looks like all the bits are 1, but actually the first bit is 0 and rest 7 bits are 1. You have actually only 7 network bits in class A if you will consider the classification. And in class B, we have 16 network bits and 16 host bit, equally host bits. And in class C we have 24 network bits and 8 host bit. See, in class A we have lots of host bit. In class C we have few host bits, only 8 host bit. In class A we have very less network bits. In class C we have lots of network bits. It means in class C we can have lots of different network. Let's say a small organization has multiple small sites, multiple small department. Let's say in a company there are 2000 or 200 departments are there. In each department there are around 200 employees. Everyone need IP addresses, 100 employees or 200 employees. So can I use class C IP address? Sorry, not class C. Can I use class A IP address? Requirement is,
No.
understand the requirement again. In a company, let's say in a XYG company, there are 200 or 500 departments, and in each department 200 IPs are required. Can anyone tell me from which class I should use IP? From which class I should
Class
use IP?
C.
Class C.
Can I use from class A also?
No.
Yes.
You can use, but it's the wastage of IP.
how you can use, bro, how you can design 500 networks, one for each department. How many network I can design in class A? We have only 8 bits, 8 ones. Out of it, even one is reserved, means we can only design 2 power 7 network. 2 power 7 is
128.
128. Total number of class A network is 128 only. Total number of networks in class A is 128. Here I need 500 networks. I cannot use class A. Even another reason is wastage, right? In each class we have 2 power 24 IP addresses, but I need only 200 IP addresses. I cannot use class A. I can use class B, but you can say in class B, issue is again wastage of IP addresses. And apart from the wastage, like let's suppose, imagine a router. A router has a network in routing table 10.0.0.0 and subnet mask 255.255.255.0, and there are 200 users. 200 users are sitting in my LAN. 200 users. Now someone is sending traffic to someone, and traffic is on router number 1. What router will do? Router will compare destination IP with routing table, and in the routing table there is an entry. How many IP addresses are there inside this entry? 2 power 24, lots of IP addresses, right? Logically, router is going to scan this entry in routing table, means router is scanning lots of IP addresses. This entry and the another entry, not like this. Here by mistaken I have defined the wrong subnet mask. I was supposed to define this subnet mask 10.0.0.0 and subnet mask 255.0.0. This is class A subnet mask, na? Right, I had used class C submit mask. Even you can use any class submit mask with any class, because what I do nowadays, we are using classless. This is old implementation. Nowadays we don't follow any class. We are using classless IP addressing. This is classification. Before CIDR, how we were using addressing, IP addressing, how we were implementing IP addressing, so that you can understand CIDR, classless addressing, very easily. So this is the entry. It means there are 2 power 24 IP addresses. But only 200 users are there. And if I am going to make entry like this, let's say in routing table of router, entry 192.168.1.0 and subnet mask 255.255.255.0. Tell me, to check this route in routing table or to check this route in routing table, when router will use more memory or more CPU? It's a logical question.
In class A.
Class A, because in that entry we have lots of IP addresses. In the class C IP, you can see we have only 254 IP addresses. If 200 users are there, then this is perfect size of my network. Even I can give you the another example. Let's suppose there is one issue in your network. You are a network engineer and there are some employees, right? Around 200 employees. 200 employees are there, and some switches, some routers, some firewall, load balancer, those devices are connected, IPS, IDS, okay? And then your entire network is connected to internet. So one user is complaining, I am not able to access internet. Okay, I'm not able to access internet, or I'm not able to access any cloud application, or not able to chat with friend, manager, anything. It means there is connectivity issue on one client machine. Okay, and you have access any one device. You have find the subnet ID that let's verify the client IP address. That client IP address is correct or not. Client gateway IP address is correct or not. Right? These are basic troubleshooting. Like before moving towards networking devices, switch, router, firewall, or any security device, you will verify the client machine configuration. Client machine configuration. Now you have two entry. One is 10.0.0.0/8 and one is 192.168.1.0/24, or like this is just a network bits of subnet mask. I can also write it like this. If it is confusing any of you, let me write like this. Say, okay. So you got to know that users are using IP address from this subnet. You will imagine what? There are lots of users in this company. Lots of users, because size of network is large. And if you will get to know that, okay, users should have IP address from this subnet, it means network size is small. You tell me if network is complex, right, very large, and another side network is divided into multiple parts, smalls, where you will feel more confident, or where you can troubleshoot issue confidently, easily. Which one will be easy for you? In simple word, troubleshooting one issue out of 10,000 client machines, or troubleshooting issue out of 200 users, out of 254 IP addresses,
254, sir.
right? This is logic. Just think where I should use which class IP address. If you are using unnecessary IP address, no problem. This is private IP address. It's usable, reusable. You can use IP from class A also if you need 200 IP addresses. But it is going to make your network complex, not simple. And network should be simple. So that even if you will leave the job and any new engineer is going to join the company, they can understand infrastructure easily. Even if the company has 2000 users, total 2000 users, this company will never keep all 2000 users in single subnet. Company is going to divide it into multiple part, and it will be using IPs from class C, or even in class C we have 254 IP addresses. Sometime you will use the subnet with 100 IPs. That is what we don't have any class which offer 100 number of IP addresses. Then you will go with classless. You can also use a network subnet with 50 IP only. There will be only 50 IP addresses. And this is what now you need to learn how to design network based on my requirement. If I have 30 clients, then what subnet mask I should use, not the default subnet mask. No one is using default subnet mask in today's time. In class C you can use the default subnet mask, no problem, but it's difficult in class A, class B. The another issue with class A is, we have only 128 networks. So if we are going to use it like class full, then only 128 ISP can use IP from class A. Yes or no? Yes. After that, all the networks are used over internet, and even all the IP addresses from each class are not usable over internet, even not usable inside your network. Some are for inside for your LAN, for private, and some are for public ISP. So we need more number of networks in class A, and we need less number of IP addresses in class C. Because of that, we come up with classless implementation. But before classless CIDR, you can try to understand one more thing here. Now, let me ask you some question. One IP address 172.16.100.255. Tell me, is it a valid IP address?
Yes, sir. This will be the
Yes.
IP address.
Then tell me from which class this IP address belongs to.
B.
Tell me
Class
how
B.
many network bits are there?
16.
How many network bits are there? 16. How many host bits are there?
16.
16 also.
Same.
How many networks I
16.
can design?
2 raised to 16.
2 to 16.
What can be the first network?
170.16.0.1. Network bit.
0.0.
Yes.
What will be the second network?
16.0.1.
No. This is going to be
Okay.
second network. First network can be what? Not here. It is 16.1.0 like this. No. No, this. Not 17. It is going to be 17 or 16.1. What will be the next network? Second network.
16 dot
16 dot
16.1.
16.1.0.
0.
All of you are saying this is the second network.
17.1 or
we are
0.1.
creating
0.
subnet or network.
You said na, in this IP address we have 16 network bits. Then I ask how many networks I can get. You said 2 power 16. I am asking you, tell me first network, second network, third network, and so on. So it
Second
is
network 172.17.0.0.
okay. No, you know this is class B IP address. Class B IP. For class B, my subnet mask is 255.255.0.0. Correct? This is my subnet mask for class B. It means there are 16 network bits. First, tell me one thing. What is the network ID of this IP? How you have calculated the network ID? You can understand second network very easily. Just a minute. How you have calculated the network ID? Network ID of this
Because
IP.
it's class B now. So first two octets is the similar, and last two octets will be changing.
See, in first octet, all the values are 1. Means this is your network portion. This is your network portion. In second octet also all the bits are 1. Means whatever value is there, this is my network portion. And here decimal value 0. It means host portion. This is also host portion. So these two octet are part of my network. Here when I am asking you what will be all 2 power 16 networks, then I start from class B range. Na? This is one network from class B, and in class B like this we have 2 power 16 other networks. Not 2 power 16 because 2 bits are reserved. 2 power 14 networks. You can see class B, classification for class B. Here these are the bits. 6 times 0 to 6 times ones. So my first network can be what? First network can be 128.0.0.0, and last network is going to be what? 192 dot last
91.
191.
191. Really?
192 is class
254.
C.
One, sorry, okay, this is 191. Absolutely correct. In second octave, sorry, this is right.
255.
255.255.
255.255. This is a network ID. Is it the network?
It is broadcast ID.
This is a broadcast IP address of your last network from class.
254 last.
254 is going to be last.
255.0.0.
Yes, right.
It is going to be last valid IP address. It is 255.0.0. Here you can see how many networks are there. Tell me how many networks. How you can find that?
2 raised to 16.
Like first network is going to be 128.1.0.0, 2.0.0, 3.0.0, 4.0.0. When it will reach to 255, then 129.0.0.0, then 120, 130.0.0, till it will go in first octet 191. After that in second octet again 12255, and then host portion 0.0. These are total to power 24, sorry, not 24, 14 networks. If you will calculate, go deep here, you will see that 2 power 14 networks are available in my class B IP addresses, sorry, 2 power 14. And if these 2 bits are not reserved, then 2 power 16, because after that value is going to be what? All bits 0 means then my first network is going to be 0.0.0. It will not start from 128 then. And whenever we need to find the network ID of any IP address and subnet mask is not there, then we can use default subnet mask and we can perform AND operation over subnet mask and IP address. For an example, this IP address 192.168. Let's say 1.0 or 1.100 and tell me the network ID of this IP address. So simple. Network ID means this is a IP address, valid IP address. We can assign this to a host. Now I am asking you, this IP address belongs to which network? Because in class C we have multiple networks. In class C we have multiple 2 power 24 networks are there. Or you can 2 power 21 networks are there in class C. So this IP address belongs to which network? First you can
192.168.1.0.
okay.
Class.
First you can identify the class. So this IP address belongs to class C. For class C, default subnet mask is 255.255.255.0. After that, see, actual calculation is happening through binary. If you will convert your IP address into binary, what will be the binary of 192? Anyone?
11000000
11
00
00
00 again 0. Yeah, 4 times 0, 192. 4 times 0 more. 128 plus 64, 192.
1 plus 64, yes. And binary of 168? 68 binary is going to 1 0 0 0 1 no, 64
1 sir 0 1 1 0 0 0 1
0 1
0
0 1 0
0 1
it is 92 0 1 0 0 0 na
more than one more after 32 na one more 0 for 8
is it the binary of 168?
yes I will check once more.
No. Should
It's 90
no. That is
64
64.
plus
128 bits should be on.
1 it should be 1 0. Let me write it now.
1
Sir,
0.
it's
0 1 0 1 0 0 0. This is the binary of 168.
yes this
Yes,
one.
correct.
And binary of 1 is 7 times 0 then 1. And binary of 100
0
is 64 plus
1
yeah 0
1 1
1 1 0 0
0.
1 0 0.
Yes.
This is binary of 100. And now convert subnet mask into binary. Binary of 255 is All 1?
Yes.
2, 4, 6 and 8. Binary of again 255. 1, 2, 3,
8
4,
ones.
5,
Yes.
6, 7, 8. Again 5, 6, 7, 8. And then 8 times 0. And here you will perform AND operation. In AND operation, you all know, like 0, 0 becomes 0. Like if input is 0, 0, then output is going to be 0. If input is 1, 0, then also output is 0. If input is 0, 1, output 0. And if input is 1, 1, then output is going to be 1.
1.
So here you can see 1, 1 will become 1. 1, 1 will become again 1. 0, 1 will become 0. Now all 0. If you will multiply these ones with the 0, it will become 0. Output is going to be 0. Similarly, here 1, 1 become 1. 1, 0 is 0. 1, 0, 1, 0, 0, 0. Here also 0, 0, 0, 0, 0, and then 1. And after that, all 0. This is what? Your network ID. Network ID. I have converted my IP address into binary, subnet mask into binary, and I performed AND operation. And I got network ID. Now again, if you will convert this binary into decimal, then you will find what? Network ID in decimal. So again, the decimal value of this binary is going to be 192. Decimal value of this binary is going to be 168. Decimal value of this binary is going to be 1. And decimal value of this binary, all 0, is going to be 0. So this is what? My network ID. I can say this particular IP address belongs to this network. And this is one network in class C. Similarly, I can have another network in class C, 192.168.2.0, 192.168.3.0. All are default class C networks. I can have 2 power 24 or 21 networks in class C, and these are the 3. In each network, how many host bits are there? Host bits, you can find host bit with the number of host or valid IP address with the help of host bit. There is a formula to calculate valid host as well. So if 8 bits are free in this particular IP address, you can see 8 bits are free, which is 0. Right, so my first IP address can be 0.00001. First IP 0, which is network ID. First valid IP address can be 1, then 10, then 11, then 100. It is like this. So in decimal, you can say first IP address is going to be 192.168.1.1. Second IP 1.2, and it will go till 1.255. 255 is last IP. Again, this is broadcast. So before this IP address, it is going to 1.254, and 0.0 is network, 255 is broadcast. These two are not usable, unusable, and these all IP addresses from .1 to .254 are usable. So how many IP addresses are there? 254. Class B, in class, sorry, not B, in class C, you can have up to 254 users, client machines, who need IP address. Or other formula is 2 power h, see, valid host, 2 power h minus 2. Why I have subtract 2? 1 for network network ID and 1 for host ID, because I am calculating what? Valid host. And this h is host bit, host bits. So number of host bits in my subnet mask is 8. So if I will put value in this formula, 2 power 8 minus 2. 2 power 8 is 256. 256 minus 2. It is going to be 254. Same value. Here also you can see total IP. Here also you can calculate number of valid IP addresses. So we have, if we have more host bits, it means we will get more IP addresses and less networks. If we have more network bits, it means we will get more number of networks and less IP address. Now by looking into the class A, where we have only 8 bits for network, means we can have few networks but lots of bits are there for host. It means inside each network we have lots of IP addresses. In class B we have 16. Once 16 network bits means we will have 2 power 16 networks. 2 power 16 networks. And if you will exclude the reserve bit, then 2 power 14 network and 2 power 16 minus 2 host. Similarly from class C, 24 bits are for network and 8 bits are for host. So 2 power 8 minus 2, 256 minus 2, 254 IP addresses. Let me ask you some more quick questions, like let's say 10.255.1.100. 1.100. Tell me, this IP address belongs to which class? First of all, is it a valid IP address?
Yes, sir. Valid IP address.
Okay. Then tell me, this IP belongs to which class? To identify the class, you will only check first octet
Class
value.
A.
It's class A.
Octet, second octet, third octet, and fourth octet doesn't matter to identify class. Yes, na? Only
Yes.
first octet
Yes.
value matters. So if value in first octet is 10, it means this IP address belongs to class A. And the default submit mask for class A is 255.0.0.0. Now you don't need to perform AND operation by converting IP and submit mask into binary. You can simply imagine here that in first octet we have all ones. So if I am going to multiply 10 by 1, I will get same value. But in second octet, third octet, and fourth octet, I have zeros. If I will multiply this by 0, then I will get 0. It means network ID is what? 10.0.0.0. Second, now 172.60.50.35. Tell me the network ID of this IP address. Network ID.
172.16.0.0.
172.60.0.0. Because we know this IP address has 172 in first octet, it means this IP address belongs to class B, and default submit mask for class B is 255.255.0.0. It means I need to multiply this value by 1, this value by 1, and these two value by 0. I will get this output. So simple. Right? And like you have this formula, 2 power h minus 2 to find the valid host. 2 power h minus 2 to find valid host. Similarly, there is a formula to calculate networks. Number of networks, 2 power n. Number of networks. This h is host bits.
0.
And this n is
Network bits.
network bits. So if I will ask you number of networks in class A, you can say 2 power n. N is for class A submit mask is
8.
8.
8, sir. 8. 8, yes.
In exam, you will have two options, 2 power 7 and 2 power 8. It means 2 power 7 is correct, not 2 power 8. Definitely we have total 2 power 8 because we have 8 network bits. But for the classification, I have reserved first bit, and which is
0.
0. Right. So imagine in class A, we have only 7 free network bits. So 2 power 7. In class B, 2 power 16 minus 2 because 2 bits are reserved.
14.
So
14.
14. And in class
Yes,
C,
14.
2 power 21.
21. Yes.
But now I have one requirement in my company. Let's say in my company there are 4 departments. 4 departments. And in each department there are 10 users who need IP address. Tell me from which class I should use IP.
Class C, sir. Class C.
Okay, if
Class
you will
C.
use class C, if you will use class C, then your first network can be like 192.168.1.0/24 or 0, 192.168.2.0, and 192.168.3.0, 192.168.4.0, correct?
Yes.
You can use these 4 networks from class C. How many IP addresses are there inside each network?
Yes.
254.
24.
55.
54. Yes.
254. And how many IP addresses are required?
Only 10.
10.
10.
10.
Don't you think again your router is going to store lots of unused IP address in routing table? Let's suppose I have companies like this. This is, now what I am saying, this is one site. You can say branch 1, my first site. And like this I have 2000, I have 2000 branches, 2000 sites. So in each sites you will have 4 class C network subnet. Can anyone tell me the size of routing table? How many routes will be there in this routing table? Routing table size 2000 multiply by 4 na, 2000 multiply by 4 means 8000. Okay, if your router can handle 8000 routes in the routing table, you can use class C IP address. Whatever IGP protocol you are going to learn, like you all know the OSPF. You know OSPF routing protocol has a limitation. It can handle up to 1500 routes only. So in this company, can I use OSPF routing protocol for routing?
No.
No, sir. No.
This is not the exact value. This is like around OSPF can handle around 1500 dots, and this is real. Right? This is not example. All your IGP protocols can handle up to 1000 prefixes. You can say around 1000 prefixes. Somewhere it can work with 2000 as well, but not more than that. Here I cannot configure OSPF routing protocol. So what is the solution? What is the solution is, instead of using 192.168.1.0 and subnet mask 255.255.255.0 for one department where I need only, let's say for department 1 where I only need 10 IPs, where I only need 10 IPs, instead of using this IP address, what if I will increase number of network bits? If I will convert this submit mask into binary, then binary is going to be what, guys? Binary is going to be what? 1111 dot and 2 4 5 6 7 8. This is binary of my submit mask. What if I will increase one more network bits here? If instead of using 8 host bit, if I am going to put 1 here, then my subnet mask will become what? 255.255.255.128. What happens if I have increased the number of network bits? It means number of network is also increased and number of host is decreased. Yes or no?
Yes.
Yes.
Number of network is, because definitely I need lots of networks. You can see the organization size, but I need less number of IP addresses. So if I will increase one more network bits over here, it will become classless. Then is there any class with this subnet mask? No, there is no any class with this subnet mask. If you are using this subnet mask, it means you are using classless. You are not following any class. Now can anyone tell me how many IP addresses are there? Formula to calculate valid host is again same. 2 power h minus 2. but this time h is reduced. Earlier h was 8, now h is 7. So 2 power 7 minus
Prashant,
2.
can you please mute yourself?
2 power 7 minus 2 means 128 minus 2, 126. Now you have 126 IP address. Still this is more, I need only 10. Let's do one thing, let's increase one more bits over here. Let's convert one more host bit into network bits. If I will make it to more network bits in 4th octet. Now my submit mask will become 255.255.255.192. Now how many valid hosts are there? Valid host
62.
2 to the power 6.
64 minus 2, 62. Still this is
62.
more IP address as compared to 10 IP. So let's do one thing, let's increase one more network bits. Even I need lots of networks because I have 4 departments in each branch. Let me increase one more bits. Now what will be the submit mask? 255.255.255 dot
2 to the power 5.
224.
No, 192 plus 64 plus 32.
Subnet mask is going to be 224 na here.
Yes.
128 plus 64 plus 32, right? And how many valid hosts are there now?
30.
2 to the power
30.
70. Yes.
And if I am going to increase one more bits, if I will borrow one more network bits from the host portion, let's say 4 network bits and 4 host bit in 4th octet, my submit mask is 255.255.255 dot 240, and number of valid host is
2 to the power 4 minus 2.
2 power 4 is 16 minus 2,
Yeah.
14.
Yes.
14.
14. Yes.
I need 10 IP addresses. Don't you think this submit mask is perfect for me? Like if I am going to use this submit mask, I will have different networks. Now I will have different networks inside this single big network. I'm going to tell you the benefit of that also. See, now my network ID is 192.168.1.0 and submit mask is 255.255.255.240. In CIDR, CIDR is nothing but network bits representation of any IP address. Like in submit mask, we have both network bits and host bit. But if I'm only going to represent the network bits, that will be called as CIDR. Either you can represent this IP address or network ID in this way, or you can represent it like this: 192.168.1.0 slash 28.
28.
24 plus 4, 28. Both are same. This is subnet mask representation. This is CIDR representation. CIDR stands for classless interdomain routing. It is classless interdomain routing. And this network, now inside this network, only 14 valid IP addresses are there. Only 14 IP addresses are there. This particular thing is called subnetting, and this is small network which you got from this big network is called subnet. What we called it, so either you can call it sub network, or you can say subnet in short. Meaning is same. Subnet means a small part of big network which we have done, like we have divided the large network into a smaller part. And formula to calculate subnet is, now let me tell you how you can find the subnet. And before subnet there is one more thing, that is block size. Now definitely my second network is not going to be 192.168.2.0, correct? Because 2.0 is second network when I am using /24. Now we have increased the network bits, we have more networks, we have divided. It means what is the second network? Now you can find the second network with the help of block size. Block size is going to tell you the size of your subnet, the small network. Formula to calculate block size is 256 minus subnet mask of your last octet. Last octet means subnet mask of that octet where last one is present, last network bits is present, means 240. It is going to be what will
16.
16. So 16 is the block size. Total 16 IP addresses are there inside your network. 2 are reserved, one for network ID, one for broadcast ID, and 14 IP addresses are usable. If I will ask you, tell me all the networks, then first network is 192.168.1.0/28. Second network is 192.168.1.16/28. Third network is 192.168.1.32/28. Fourth network is, and so on. How many subnets are these? Are not networks, these are subnet. The difference between networks and subnet is network is the default networks with default subnet mask in classful routing. In classless routing, my network same network ID becomes subnet ID, subnet. So how many subnets are there? You can find that with the help of this formula. Formula to find subnet is, just check how many bits you have borrowed, right? Like I can see this IP address belongs to class C. Class C, for class C default subnet mask is 255.255.255.0, or this is the default subnet mask. This is the default subnet mask, but I am using what? This subnet mask. It means I have borrowed 1, 2, 3, 4 bits. So 2 power 4. What value? 2 power 4, 16. I have divided big network into 16 subnets. Subnet is a small part of your big network, and you can find all the subnets here. Like this is your first subnet, second subnet, third subnet, fourth, sixth, seventh till 16th subnet. In Cisco can ask you directly questions in exam like this is a IP address 172.16.100.50/28. Tell me the third network or third subnet ID. Subnet ID of third subnet, third network, and with the help of block size you can find it. And inside each subnet, how many valid IP addresses are there? You can calculate it, right? It is not 24 here. It is not 24. It is going to be 192.168.1.32/28. And you can also verify it. In last class we had used packet tracer tool, packet tracer software to see the MAC address table or how switch forward traffic or learn MAC address. Again in packet tracer, what you can do, you can try to configure these IP addresses. For an example, see this is my router, and let's say my router is connected to a switch, right? And I am going to configure one IP address over here, one IP address on router interface like this. Enable config T interface F0/0 no shutdown, and let's say IP address 192.168.1.32 255.255.255.254. Will it accept this IP address?
Yes.
No, it will not accept
No.
this IP address. This is what?
Network number.
ID, subnet ID. What? Here I have told you, see, this is third subnet, correct? This is my third subnet. So if you will try to configure this IP, it is giving you the error. Bad mask/21 for this address. But if I am going to configure same address with default CIDS, default subnet mask, definitely will accept, because now this is a valid IP address. Now this is a valid IP address. So whenever I am asking you any IP, that this IP address 192.168.200.250 is a valid IP, you should ask me, Praphul, tell me the subnet mask, then only I can tell you is it a valid or invalid. Getting my point? Subnet mask or
Yes.
CIDR value can only tell you that IP address is valid or invalid. When I am configuring same IP address with this submit mask, it is giving me the error, and same IP address with this submit mask is working. Now here is a question for you before leaving this class, and from here we'll continue in next class tomorrow. Question is, I have a IP address 10 dot or 110 dot 250. No, let's make it easy. 10 dot 10 dot 10 slash 19. Tell me the network ID or subnet ID. Subnet ID of this IP address. First, is it a valid IP address? If yes, then tell me from which subnet this particular IP address belongs to. First, we have learned the IP address belongs to which network. Before that, we identify the class, and now I am identifying the subnet ID from the IP address. Can anyone find it? Do it. If anyone have understood what I am trying to say.
Sir, block size is 206 minus 224.
How you have calculated the block size? First of all, tell me how many bits I have borrowed here.
3 bits. No.
11.
You can only answer when you know the classification. First, check the first octet
8
value.
bits.
This is
11
class
bit.
A
11
IP
bit.
address. For class A, 8 bits are network portion. Here I am using 19. It means we have
11.
borrowed 11 bits, right? In binary, or subnet mask is going to be like this. In first octet, all the bits are 1, 5, 6, 7, 8. Then 1, 2, 3, 4, 5, 6, 7, 8, 16, 17, 18, 19. And
19.
5 bits are 0. And in fourth octet, all the bits are 0. This is what submit mask in binary. Now you can find the submit mask in decimal also, 255.255.
224.
224.0. Now you can find the block size, 256 minus submit mask of that
224.
octet where last one is present, 224. It is going to be what?
32.
16.
32.
32. It is going to be 32. First subnet is going to be what? 110.0.0 slash 19. Second subnet is going to be what?
110.0.
132.0.0 slash 19. Next network 10.64.0.0 slash 19. And now you can see this IP address. This IP address, it means this network, the first subnet is ending over 110.31.255.255. And now see, this IP address belongs to this range. If yes, then this is the network ID of this IP address. Yes or no?
Yes.
Second subnet is ending on 110.63.255.255. If I am going to ask you, tell me the subnet ID of 110.60.50.90 slash 19. What is the network ID or subnet ID? You can say 110.32.0.0 slash 19. Yes or no? Because this particular IP address belongs to this range, na? This range, see? From in second octet, 32 to 63 belongs to second subnet. So this IP address belongs to second subnet. This IP address belongs to first subnet. Now here is a easy question. 192.168.1.200 and slash 25. Tell me the network ID of this IP address. Most of the people say 192.168.1.0. Is it right?
No.
1.0?
1.128.
Exactly. This is 1.0. 1.0/25 is not the correct network ID of this IP address. No. You can even test it again in your packet tracer. Like if you will configure this IP, let's say IP address 192.168.1.200 and 255.255.255.128, then you can check what is the network ID, because router is going to calculate network ID to build a routing table. So you can verify routing table. So IP route, and in routing table you can see the network ID. It's 1.128, right? How? See, this IP address belongs to class C. For class C, default CIDR value is 25 and I'm using 20. Sorry, default CIDR value is 24 and I'm using 25. It means I have borrowed 1 bit. It means subnet is, how many subnets are there? 2 power 1, 2. Means we have divided my main network into 2 parts. Right, main network is 192.168.1.0/24, right, from class C. Your main network 192.168.1.0/24. This is your main network, right? Default network with slash default subnet mask. Here you have borrowed 2 bits, and block size is 256 minus subnet mask of,
128.
yes, 128, 255.255.255.128. So block size is going to be 128 only. It means my first subnet is 192.168.1.0/25 and second subnet is 192.168.1.128/25. In each network, how many users are there? How many usable IP addresses are there?
126.
From 1 to 126.
2 raised to 7.
126, yes.
Yes.
Right? There can be 126 users. Now imagine I have a switch, and here I have some users, right? In one department, around 100 users in HR, and 100 users in, let's say, sales departments. 100 users are in sales department. I have given one subnet, a small subnet, 192.168.1.0/25 to HR, and one subnet 192.168.2.0 slash sorry, not 2, 1.128/25 to sales, HR and sales. Okay, and then there is a router. Even on the router, if I want to summarize the routing table, size of routing table, I want router should only install one entry in routing table. I can say, router, you can keep it this, because both the small networks are part of this big network only. Yes or no? This is my main big network, and here I have divided into 2 parts. So router can even summarize the route prefix in the routing table. Now tomorrow I will tell you how you can design a subnet, how you can plan IP addressing for companies, for organizations, based on your requirement. Before that, if you want to practice, then you can take this as a challenge. Let's suppose in, again, same XYZ company, in XYZ company there are 4 departments, and in each departments 30 users are there. So network subnet ID for each department, number of usable IP address, broadcast ID. As a network engineer, you should know everything. Like in, let's say, HR department, manager want to send some file to everyone, only in HR department. So definitely manager will not broadcast it on 255.255.255.255. This is broadcast address for entire IPv4 network. Even HR manager is not going to broadcast it on 192.168.1.255. What happened here? Users in sales department will also receive that broadcast message. Then what is the broadcast address of second subnet? No. This is the broadcast address of second subnet only. If I will tell you, ask you 127./25, is it a valid IP? No.
No,
This
sir.
is
It's
the broadcast
broadcast
address
address.
of first
Yeah,
subnet.
yes, this is broadcast ID.
So
Yes.
HR manager
Yes.
will send file on this address, not on 255, not on 255.255.255.255, correct? So that
So
everyone inside the HR department can receive this file. Yes, go ahead.
so you means within in my network.
Yes, within my subnet.
Oh, okay. Yes, subnet. Yes. Sir, can you go back to the first example 110.10.10.10/19?
10.10, here it is.
Yeah. So the first network should be 110.10, I think.
Yeah,
Dot
this is,
32 dot.
yeah, it's 110.
Mm.
Correct. In the CCNA drive folder, there is a file with name subnetting. There are some 20 important questions, and I have collected those all questions from the exam paper, only CCNA exam paper. Those are CCNA exam questions from subnetting topic. You can try to solve that PDF. There are some easy questions and some tough questions. You can try to solve, or let me show you that as well once. Like now I'm expecting you all have access to this folder on my drive, PM networking notes. Inside CCNA, there is one file with name subnetting. Just search for it. Here you can see subnetting Q&A. If you will open it, here you can see some questions. Like very first question is this one: enter the last valid host on the network that the host this one is part of. First of all, tell me, is this IP address valid IP? Is it a valid IP? If yes, then tell me the network ID of this IP, subnet ID of this IP. After that, tell me the last valid IP address, not broadcast, last IP address, and then you need to mark one answer. Easy. Similarly, second question, third question, so around 20 questions are there. You can try to solve it. I will also discuss these questions in class. If anyone have any confusion, any question, whoever are fresher, if you are struggling to understand the subnetting or IPv4 addressing, please let me know. No worry, we can spend one more day on the subnetting, but once you will understand these basic fundamentals, it will be very easy for me to teach you the advanced routing. All the routing is going to work over here only on your subnets, right? Clear?
Yes, sir.
192.1
How
dot
can I get your, that files, that PDF? I don't have access to that. Could you please share the links?
link is